Welcome, everybody. Thank you for attending our webinar for a introduction to our digital course, Snap into Electronics. We're very excited to give everybody a good preview of what this course is, everything that's involved. Today with me, I got a panelist, Liz Eversole. Thank you, Liz, for coming. Yep. Hi, Liz. And so today, what we're going to really do is deep dive into the course, kind of give a good overview about what it is, how it's designed, how it's formatted, and how you can really leverage this new course right away into your classroom. Now, to get started, I always like to kind of get a poll of who's all attended here. So bear with me for just a sec. I'm going to run a poll. I'm going to launch that. So you should see a poll on your screen right now. It's just kind of a good idea for me to understand who's all watching today. So if you're elementary, middle school, high school, if you're in an educational institution, et cetera, that helps us kind of gear this webinar specific to your needs. But as you're doing this tool, I also like to remind our audience that if you have any questions throughout this, feel free to put that in our chat. We're going to be monitoring that along the way. Also, this webinar will be recorded. So say if you did miss this live session and you want to kind of get back to us, feel free to look at the recording. That'll be sent in the follow-up email. And there is a survey afterwards as well. We kind of use that survey to kind of say, hey, what went well? What didn't you like? What are things you maybe want to utilize throughout the school year, maybe different topics, et cetera. So make sure to check that out at the very end as well. So let's check back to the poll. Looks like there's going to be a mix of teachers with us today, and that's okay. This course is designed for K-8, and it really focuses on electronics, circuitry, and really embeds the engineer design cycle. And we refer to that as the EDC. You might have heard of that as the engineer design process, but it does a really good job of incorporating all those different science concepts, but in a STEM challenge format that allows the students to really critically think and hone their soft skills. So without further ado, let's jump right into this course. There's 15 different topics that you're going to see right here. You're going to notice there's more on the second page. But what we're going to do first is we're going to go to the start module. This is going to have all the documents that you're going to need to be able to help you get started within this course. So the first document we're going to start with is the course teacher's guide. So I'm going to pull up the course teacher's guide real quick for you to be able to see. And the teacher's guide does a really good job of giving you a great introduction to the course, going to explain how are some different applications that you might utilize this for. A lot of times what we hear is that there's some still uncertainty whether or not teachers are going to be teaching remote. Are they going to be in person? Is there going to be kind of a hybrid situation? So this course is very flexible in that you can be completely remote, or conversely, you can be in person and or hybrid. So there's a lot of flexibility within this course, and I'll kind of explain that as you get to watch a little bit more of this. Here's the list of the total topics that you have, the 15 different topics. Then it gets into the module format. So every module is going to follow the same format. So when you're going from one topic to another topic, it's going to be really easy to follow. Visually, it's going to be a little bit easier, but essentially there's a teacher's guide. There is a topics or activities that they're going to be doing within the topic. There is a STEM challenge journal, knowledge check, and then also additional resources. And so we'll go into a couple of the different topics today just to kind of give you an idea. Again, this is for K-8, so we're going to kind of do more of an elementary version topic, and then we're going to also do more of like a middle school topic. There are course standards in here. In this case, it is aligned to NGSS standards and the engineering design standards within NGSS. There are materials that are included with this. We want the students hands-on, engage with this. And then there's also some recommended everyday classroom supplies that they can use to enhance or enrich their activities as well. Then, of course, it gets into the using the course, but that's essentially what the main teacher guide does, is kind of gives a really good overview of everything there. If you want to look at all the different topics and the standards that they're aligned to all in one document, that's what you would use right here. And then we also have getting started with some of the activities. So just a lot of great resources right here in the Start Here module. Off the left-hand side here, you'll notice that there's these little plus buttons. This is kind of more or less your navigation pane to get throughout the course. Makes it very easy to be able to navigate from topic to topic. But the two topics that we're going to be focusing on today are simple circuits And then we're also going to be focusing on coded communication. So these are the two topics that we're going to be focusing on. But before we do that, we're going to actually jump into the Snap into Topics Guide, Hardware and List Supplies. And the reason being is because a lot of times we get the question saying, okay, what kind of materials are we going to need to be able to run this course, right? So here, I'm going to pull this up in an easier format for everybody to be able to see. Well, actually here, that's probably not the best format. There we go. Okay. So essentially right here, this is going to give you what grade level that each of the different topic has. It's going to explain what is the name of the project. And this is going to come into play a little bit later. I'll show you just a sec. And then it also gives you the title of the STEM challenge. So the STEM challenge is related to an everyday problem where the students are faced with some kind of technical requirements that they have to build either with the snap circuits and or additional supplies to be able to solve that challenge. So as you go through here, you can see the multiple different grade bands, the different names. As you get down into here, then we get into the individual parts. So remember I said the title of the project. So the electrical light and switch project, you're going to need these different supplies. So this is a great document because then you can say, okay, if I'm going to be doing one project to the next, what kind of supplies I'm going to need? And it's going to be an easy format that's visual for you to be able to utilize. So just a great document to also have in the Start Here folder. All right. Now we're going to jump into one of the modules. The first module we're going to start with is the simple circuits. Like I stated before, all of the topics are going to have to follow the same format. The teacher's guide, we're going to jump into that first here. And what's really nice about the teacher's guide is that it's going to have all of the student objectives listed very nicely for you. It's going to have a table of contents just in case you want to jump around, but essentially there is a recommended suggestion pacing guide. So sometimes it's like, okay, how many days or activities are you anticipating for any of these given supplies or things that we're going to be doing? Then it's going to also explain the different resources you're going to need with that particular topic. So when we get into the activities, the snap circuit activities, these are the resources and things that are going to be needed. Same thing when we get into the simple circuits, and then also the last part, which would be the STEM challenge. We also have, of course, the standards that it aligns to. We have the simple circuit activities, a little bit more explicit explanation, and we'll jump into this so you don't need to go into this. But essentially, there's a lesson warm-up and other things, vocabulary, materials needed, activity materials, and then again, the projects that you're going to be using within this unit. So let's jump into the activities. I think this is kind of where the heart is. You can go to full screen mode. This allows you to be able to teach with this course just like we are on today. Or conversely, if you wanted to, you can print off this this activity information for your students as well. In here, we have the lesson warm-up. This is going to get them introduced to this topic. In this case, simple circuits. We're going to have activity materials. Activity materials are the things they're going to need for the Snap Circuits project or the STEM challenge. This is step-by-step instructions and videos and also to 3D models of what they're going to be building with the Snap Circuits. And if you haven't heard Snap Circuits before, Liz, do you want to hold up really quickly just an example of what that would look like, the Snap Circuits materials? So those are the pictures of things we're going to do. Right now, she has a switch there that she built a simple circuit that she's turning on and off. It's just an easy way to be able to snap on. So if you pull off one of those, say, Liz, if you pull off that switch, can you show the back of that switch or the light? See those metal pieces there? That's where the conductivity is happening. So when she snaps in there, she's actually connecting the metal pieces that goes from the battery source, goes through the circuit, lights up the light, and then completes the circuit on the other side through the battery. So just like at home, and when we turn the light switch on and off, that's what she's simulating is a simple circuit. And that's what the Snap Circuits are. So we built these projects using these tools, materials, and make it very easy and convenient for you to be able to introduce in your classroom. And then, of course, we have our STEM challenge. And again, this is unique to some kind of real world application. So when we begin the activity, this module is set up where it could be student led. You're going to notice as I scroll down, it's very immersive. There's graphics, there's images, explanation, vocabulary, everything that you would need to be able to introduce this concept. Again, a video introduction to what is circuits, what is the explanation of that. And then we can have some different discussions. Some of this does have some readability. So this is going to read these questions out loud. What shape can a circuit be compared to? So We do have those built-in features as well. As you continue the course, you're going to notice that this is keeping track of our progress, and that is normal. That's the way we know where our students are. So again, if students are doing themselves, or if this could be taught in front of the classroom, you kind of have a good idea of where you are within any of the topics. So again, very easy, allows you to get familiar with a lot of the terminology that you're going to be using in this simple circuit. So even at the elementary age, the students can be successful with the content. Once we jump into the active materials, this is where we're going to get into that list of snap circuits. So it's going to say very explicitly how many battery holders, what kind of wires we're going to need. In this case, we have a 3 snap. There's 2 snaps, 4 snaps, 5 snaps. We have a slide switch. We have a base grid where we're going to be able to put all of our snap circuits onto. And then, of course, we have the lamp. And that's what Liz was basically showing right there. If you look at her screen again, she basically has one of those same designs. She has the switch there. You see the blue 3 snap piece there with the light turning on as she has those batteries there. What's really nice about the battery holder too is it has the negative and positive terminals on there. So it really allows you to be able to understand the electron flow throughout your circuit as well. So as you continue scrolling down, you'll also notice that there's recommended classroom supplies here. These are things that can add to it, right? And when we're building simple circuits, this can transition into what is a, conductivity, what are conductive materials or non-conductive materials, things of that nature. So just a lot of great extension opportunities within here. Once we jump into the project itself, now we're going to get into, okay, what are the objectives? What are we trying to do? So we want to show electricity turns on and off with a switch, just like you would at home. So now we need some building blocks. Okay, what are the materials that we need? Again, it's going to reiterate these materials, but that might not be what we need, right? We might need to know specifically, okay, what is this exactly? Well, it's a battery holder, right? It holds 2 to 3 AA batteries that you could be able to use. In this case, Liz, I think, has 3 batteries on her battery holder. And so there's some batteries holders that have 2, some have battery 3. So she, in this case, she needs 3, but she would only need 2 for this case. So just be aware of that. Then, of course, we have our little snap wire, but this is just a great visualization for your students to be able to understand what are these materials and what are they used for. It just gives that good background knowledge. After we get the background knowledge, now we're going to actually build our circuit. And so we're going to have a visual, just like you saw on the screen. She had the 3 battery holder. It's going to give that step-by-step instructions. Now, that little grid format, there are actual letters and there are numbers on there, I believe, on that base grid. It's hard a little bit because it's a little translucent. Okay, if you hold it up a little bit closer, you can sort of see, yep, you can see that. So you see that 6, 7, 8, 9. So along the top axis, that you're going to notice that there's numbers. Along the horizontal axis, you're going to notice that there are your letters. So there's the letter A. So A1 is going to coordinate with A1 snap circuit. So that's where this directions comes into play. And so if you don't want to use these instructions, you can always use these videos. These videos are nice little tutorials, allow you to be able to see visually, okay, what materials do I need? How am I going to put this together? And actually building the circuit from scratch. So it really just walks you very nicely through that process. So if you're a visual learner, if you like to read and have all different modes of learning, it's going to be accessible for you. So it's just a great way for you to be able to coordinate. I do know that when we're going through this course, that if you want, oh, I do see in chat, sorry. I will slow down a little bit here. When I get excited, you'll notice that I'll start talking very quickly. That's typical of my behavior. I apologize. But if you want to, like I said, this video is just a great way for you to be able to utilize in addition to all of the different course and materials. So definitely recommend watching the video. As you scroll down, you'll notice there's also this 3D model here. And you might be saying to yourself, well, why do we have a 3D model? Well, it's because we really want students to be able to visualize and see exactly what they're building. So again, you have the numbers on the vertical axis, you have the letters on the horizontal axis, and you can see visually what kind of space is needed, how you're going to build this design up. And so they can really double check, hey, were we successful in the design? Maybe some things I might be missing. Another thing to help them also with that process is a troubleshooting area. Oftentimes, as educators, we go into that process like, wait a minute, why does this circuit doesn't work, right? Well, if there's a break anywhere, it doesn't matter how small, it's going to mean that there's no electricity, right? It's just like at home, we have that light bulb that goes out. Well, 9 times out of 10, that light bulb is the reason why it burnt out. We have to replace the light bulb. Well, if we replace the light bulb and it still doesn't work, well, maybe we check the light bulb on a different circuit, maybe on a different area. Maybe if it works there, then we know maybe there's something wrong with that circuit itself, the wiring. So there's a lot of things like we do at home that we troubleshoot. We want to instill that in our students too. So, hey, are the batteries fresh? Are the snap circuits securely connected? Did you hear that snap physically, or were they not fully connected? It does matter. It makes a difference. So I like that. And then we also get into understanding the circuit. How does the circuit really work, right? When we slide the switch, where is the current flow happening? How is that actually working? Well, if we know electrons, and it goes from the negative to the positive terminals of your battery. And so as students start to begin to conceptualize and understand that a little bit more, they're going to be able to start to build their own circuits and be very confident in their building. So this does a really good job of walking through everything, the schematics, understanding the different areas. It's not just learning about circuits, but also related to real world circuitry as well. After they complete this project, then of course, then we're going to get into the STEM challenge. So the STEM challenge is really getting related to real world using the engineer design cycle. In this case, they're going to create a multicolored flashlight that can be used to illuminate in the dark space. But then they're going to also write a story about that and perform with puppets and props. So something that you would see in a Broadway show or something you see in a play or even a movie, these kind of schematics, these things that are happening in real life can be simulated by something the students could do. So it does a good job of getting them related. And so they show this little tent view. I remember doing that, of course, making the animals with the illumination when I was little. But it does a really good job of walking through the engineer design cycle. What are those different phases? What is the ask phase? Well, we have to first define our problem. Then we have to do some research. Then we're going to come up with some kind of blueprint or plan. Then we get to create a prototype to see if it's going to solve our solution. Then we get a chance to improve our design. 9 times out of 10, when we first do something, it doesn't go as planned, right? Like when we're painting our rooms or painting other things, when we paint, we're like, wait a minute, that coat, I think needs a little bit more paint, or that wasn't the shade of white or red that I really was intending, things of that nature. Then we get to share our design. And this is where you get to see a lot of the innovation and creativity phase. So such a crucial phase. And I always sometimes take the next step further and say, hey, let's create a Shark Tank theme, right? Trying to create like this competition a little bit, get students kind of creativity, and those that have the best design, maybe they get an extra reward or incentive. So it's just a nice way to kind of challenge your students beyond that. So that's the challenge itself. After you get into the engineer design cycle, you'll learn it. Now we're going to apply what we learned. So in that ask phase, our problem is, okay, now we're going to create that, illuminate that space. We're going to write that story. So what do we need to do? Well, we need to create a circuit that lights up a switch. We need a filter that can change the color of the light, short story, props performance. So just like that same phase that we understand, now we're applying it to the actual problem that we're solving. And they go step by step through this process and build that. And at the very end, share and present their story. So, hey, you know, you're going to present it with licensed props and story, show others what you created. It's just a really good job of culminating the whole project for the students to be able to use. As they're doing this process, you might say to yourself, okay, what kind of form of assessment are we using? And we thought of that as well. So we use something called a STEM journal, and this is unique to every single challenge. So what you can do is you can download a physical copy of this, or you can create a Google Doc, a copy of it. So we're going to make a copy just to kind of show you what that looks like, just to kind of give you an idea of this digital journal. So again, you can create your name here. You can either do this individually as students, or they can work in groups. As you're going through here, just like you would throughout the different phases, you're going to be able to document everything that you need. So you can upload text, you can upload images, you can do anything that you would need for this project to show your final solution. At the end of that, we're going to go into our knowledge check. So this is another kind of assessment component. This is aligned to the NGSS standards and engineering standards. There's just 5 simple questions. Sometimes this could be a pre-test, sometimes it could be a post-test, depends on how you want to distribute with your class. But let's jump into this quiz just to kind of give you an idea what that looks like. And so these are sometimes short answer, sometimes they're multiple choice, sometimes they're true and false. And again, these are just easy ways for you to be able to see what the students know or not know based on what they learned, just an easy touch base point. And then of course we have the additional resources. This is nice because there's a lot of activities, there's videos, there's different games, and these all relate to the topics. In this case, talking about simple circuits. So in this activity, we're going to talk about open and closed circuits, right? We're going to do practice. We're going to compose a few simple circuits as a power source, a load, wires, everything, just like a schematic would be. Then we're going to do a little video to kind of give a little bit further introduction to maybe help supplement their knowledge about this. And again, in that pacing guide, this is going to where you're going to be able to see these additional resources and kind of where they fit in to those everyday activities. And then here's a little game, right? So here's a little power source. We have 3 LEDs. In this game, you're going to practice connecting these circuit parts and create a circuit. So it's just another way for them to understand, hey, in order to have a circuit, you need some kind of energy. And then sometimes you'll have wires or a source or a path where this electrons will flow. It's just a nice way to be able to go through that. So again, this is just the simple circuits that we can do. This is just one activity. Now we're going to jump into our next one, which is called coded communication. So just like the format of the other different module or the topic, we have a teacher's guide that's going to have everything that we need as far as the student objectives. It's going to have a similar table of contents with the pacing guide. It's going to have the standards. It's going to have the activities, very description, and all the materials that you would need to build a project. So this is the project that we're going to be building shortly. I know Liz is excited to show her project that she built and took the time to do that. If we want to take that up there. Yeah, absolutely. And it flashes colors, which is a bonus, right? I know kids get attracted to that, things that move, they light up. So sometimes it's nice to have that pre-built ahead of time as well if you're teaching this, and just to kind of give them a visualization to show what they're going to be building. Then they get the main idea, but then they can get into the nitty-gritty details. So let's jump into the activities again. So this is a more advanced lesson. Again, similar setup. We're going to do the warm-up, kind of really get them introduced to some vocabulary. Coding is important because this course is really designed to get them from the very basics all the way into the advanced where they get to code and be able to manipulate. And so snap circuits, I don't know if you knew, everyone, but now they can begin to code with circuitry and robotics. And we'll kind of explain that in a little bit here about what a microcontroller is and how does that all relate to this. So again, does a really good job of giving the instructions on everything you would need to be able to get started with this, because we are going to do some coded coding with our circuits. Then we get into the activity materials. Now this is where it's going to get a list all of the different snap circuit components. And one of the things you're going to see there is this microcontroller. Now there's 2 different visuals, and Liz will hold it up. One is like a blue color and one's a white color. They're essentially the same thing. They're just skinned differently, right? And so this little controller right here has different components on there. You might see D1, D2, an A, a ground, a positive. So you have your negative and you have your positive terminals, and then you can connect your circuit to that. And these little graphics are going to walk you through it step by step in understanding how you would be able to use this microcontroller. So we're going to be using some LEDs on here. We're going to use some of our wires. So instead of wires, again, we're using these little hard components that they're calling wires, and then our base grid. Again, other different materials that you could utilize within this project. Let's jump into the project itself just to kind of give you an idea what it is. So we're going to be coding 5 lights, and we're going to make sure that we can run this program. So just like you would in the other one, you want to reiterate what we're going to be using. And then if you didn't know what they were, we can go into description. So if we're looking at a microcontroller, what is a microcontroller? Well, this is going to be able to power everything. It's kind of has this Bluetooth, right? It's going to be able to connect to your device. So sometimes if you have a phone, whether or not you have a Chromebook, a tablet, etc., you're going to be able to use this. And then you're going to have all the different components. We're going to then assemble this project. Again, it's step by step. So we're going to build this. So I'm going to actually have Liz show this circuit real quickly, show it in action as we built it. So what you're going to notice is that the circuit is going back and forth, and she has it on loop right now. So we have our power source, which is by her finger down there, the 9-volt battery that is connected to the wires, which is up to the meeper bot right there. Yep. And then you have your switch that she turns on to make sure we have power. And then what the white microcontroller is doing is communicating to all of the LEDs. So it's saying, hey, green light, go first, red light, then yellow light, then blue light, then red light. And it keeps rotating back and forth, back and forth. So it does a really good job. So there's 2 ways that you can set this up. And oh, thank you, Liz. Right there is where she has the code, and it's just going through the code through the app right there. So it's a drop and drag down value to be able to walk through this. And I will be able to show you too on my screen as well as you're building through the code. So it's just a really good job, easy way to do this. Again, we have the step-by-step instructions. Here's the D1, D2, A, D3, D4, the timing of how long you want it to go. So those are milliseconds. So it's really quickly. So it's basically 1 second, 1 second, 1 second, 1 second, 1 second. And then we get into the LEDs of where we want to go. Let's watch this video just to kind of show you an example of what that would look like in real time as you're trying to build this. So as the builders, as we get it all set up, then they're going to start to build with the code. So the next phase, as we get into here, we're going to connect with our device. It's going to scan for with controllers. Now it's connected. So we're going to say, okay, we're connected to our device. So now it's connected. So now we're going to actually start building all the different codes. So D1, we want that to go at a certain time frame. We're going to add all these other ones, and it's just a drag and drop. Notice that the D1's on the left side, it's pulling to the middle interface, and it's showing that we're starting, and it's going to replay that code. So as they're going through there, it's going 1 light to the 2nd light to the 3rd light to the 4th light. And you can see it can goes back and forth, back and forth. And you, depending on how you place that code, you actually build a circuit. So not only are they building circuits, but now they're extending into coding. And the reason why we like this so much is because this is a natural progression into robotics. A lot of students think like, oh, it's a robot, it just goes. Well, no, there's a lot of circuitry involved. There's a lot of coding involved. And this gets them introduced to those basics. So by the time they get to a robotic, they really understand what does it mean to that it makes a robot a robot. So again, here's the schematics that you can build. There's a 3D model. You can use the battery holders or the 9-volt, depending on how you want to be able to build your model. And it does a really good job of laying that out for you. There are some zoom in capabilities, and it will explain that. So as I was zooming in, zooming out, if you're curious about how do I do that, because this uses Tinkercad software, it's just a 3D design. Typically you would 3D print with Tinkercad, but you can also use models with Tinkercad as well. I sometimes like the idea of using it with the science models because in the NGSS, as you know, building models is part of the learning process. Then we get, again, of course, getting into troubleshooting. Does this work properly? Is it facing the right direction? The batteries, etc. Gets into the schematics of this, and then getting understanding the circuit. So if you didn't understand how does this actually work, it's going to break down into the time, the voltage settings. It's going to talk about the output, the microcontroller, essentially. How is it communicating to all of your little circuitry components? Here's your wait feature. How long do you want it to wait for between going one LED to the next? Liz had it on loop. That's how she was able to allow it just to stand up freeform and continue going back and forth. And then you can also save this code. So that's the benefit of this app, is that you can get to save this code and you can send it to a teacher. So you can theoretically do this remotely as well. We're not going to get into the specifics of that, but if you are interested, feel free to reach out to us and we can do a more specific demo for you. And then you got this H and L right here. Liz, do you want to talk briefly about what the H and L stand for? Oh, sorry. I got asked to unmute there. Here, hold on a sec.
All right. Can you hear me, Jordan?
Yes, we can.
Yep. So H and L just give you two different voltages to let students illustrate Maybe if you have a chime, if you're on high, it's very loud, and then you change the voltage to low, then it gets a little bit softer. So really just to help them understand voltage and current and the amount of power that's coming through the microcontroller, you're controlling that as you, what goes to each of these particular components. So you can make your lights go brighter or dimmer, your chime go louder or softer. So.
Yeah. And what's really great about that feature is a lot of people have those toys, right? Those little, like if you want to bring like an elementary pre-K toy into the classroom and show the dynamics, remember those volume settings where it was kind of low and then it was high? This is the same application that we're using with these controls. So it gets students to really think about how much voltage we're using. Just like if we're powering a car versus powering your everyday fan in the household, right? So, and also the misconception of resistance, right? A lot of people think, well, water is conductive, right? Well, it takes a certain amount of voltage to make water conductive. I think it's like 120 volts or something like that, or just to actually get past that resistance. But it's that whole kind of mindset that we're getting through to get students to understand the foundations and then get into the high voltage, low voltage, time units, weight, loops, etc. So just a really good culmination of pulling all this information together. So by the time they actually hit the STEM challenge, they're ready to go and really put their skills to the test. So in this case, they're going to actually create and manage a traffic light, just like you would see in everyday class, the school, that they might think, okay, well, these are traffic lights just work, right? Well, no, there's some kind of code behind that. And if you time it right, you can see that sometimes they're crosswalks. You know how it goes from okay to walk and then the flashing red light. Well, if you time that, sometimes those are set to 10 seconds, sometimes they're set to 15 seconds. And if you count in your head, you can start to pick up on that as well. So it's just something to think about as you're going through real world applications and talking about circuitry. So again, engineer design cycle is all there, ready to go. Then you get into the specifics of the application of this for the specific challenge, identifying the challenge, what you need to do. Then we're getting into the brainstorming feature of doing some research behind it, making the plan, the approving, and then sharing. Then again, of course, you have the STEM journal. You can create a copy or the digital download. So this, sometimes people like to have the hand physical copy, and that's okay. Sometimes I'm one of those that if I write it down, I'm going to remember it. So it's kind of like a PowerPoint feel look to it, but essentially it's the same thing. You can have it here, you can print it off. Here's your ask phase where you get to define your problem, upload any text or images that you're going to be doing. So it's really good in depth of way to be able to communicate. Here's your knowledge check. You can do your pre-quiz, or you can check into the questions, again, multiple choice or true or false, short answer, etc. And then additional resources as well. I know I kind of went through a lot of information right now, and a lot of people are probably thinking, okay, I'm kind of absorbing this a little bit, and that's okay. There's a lot here, a lot of great information. And again, there's 15 different topics that you can use within this course, and it's very versatile, all aligned with the NGSS standards, everything there that you would need to get started with this course. So I'm going to pause right there. I know Liz have some different circuits and things like that. Oh, great question. So, hey, can we use existing snap circuits for this course? Absolutely. These snap circuits, anything that you have in your closet, or if you've noticed that you do have snap circuits in your classroom, pull those out. You can use that with this curriculum. It's ready to go. The one caveat is that if you might need some different components like a microcontroller to be able to do the coding unit, or if you're doing the electromagnetism unit, you might need a solenoid, that little piece that has this coil, that wire that's wrapped around multiple times. You might need some of those components in order to do some of the challenges. But yeah, any kind of snap circuits you already have existing, you can use with this already. And then all I would do is go to the Start Here module, look at the different materials that you might need within the topic guide, and then you're going to be ready to go and set up for success within this program. So just a really easy way for you to be able to know exactly what you need for any of the given challenges that you have there. That's a great question. All right, I'm going to open up for any other questions. Where do I get the microcontroller and other parts? That's a great question too, Liz. I I imagine that's probably something that they probably do need to know. Yes, so Nasco Education does have a website. If you want to go to nascoeducation.com, you can collect all the different kits. Though what's really nice is we have a full kit already designed for this course. So say if you need this for your full classroom, you're rolling it out for 24 students, I need some materials for the class, you can go right to our website. We can get you set up with a kit to be able to get started with this course. And like I said, everything is there already for you. It's all science-based, but there's also a lot of math, there's STEM involved too as well. You could buy the microcontrollers. So if we go into, I think we type in Meeper, and now I'm testing my skills here to make sure I understand where these. So this is one of the different microcontroller units. We sell them individually as well. So this is just something in case you are interested. So 25 of these different units, if you want to be able to code and start using with robotics, you certainly can. And then we also have a variety of different packs of circuits that you might need as well to be able to get started with this course too. So just a plethora of different information and different materials that you might need. Feel free to reach out to us if you are interested. I'm going to actually type in here, solutions@nascoeducation.com. Feel free to reach out to us there in case you have any questions, or if you like further demo of this course or a little bit more foretell, or if maybe you would like a trial, we also allow that as well. But I think I'm going to look just to make sure I didn't miss any other additional questions that we might have at this time. But again, this is an all new digital course. I think we're currently coming up with some more information on our website. So if you don't see it there, don't feel, you don't fret. We are going to get that there eventually, but we are giving you a kind of a good preview of what's coming and what's available right now to you. Like I said, reach out to us at solutions@nascoeducation.com if you like more questions. I definitely thank you for your time today. Thank you, Liz, for joining us and building all those different circuits. We definitely enjoy that. Visuals are always key. And I'm available too if you have any additional questions, or if you would like some professional development in circuitry or using this course. We always allow that as well. That's part of the package too. So engage@nascoeducation.com. That's where you can reach out to me, and we can get back to you a little bit more information about this course if you would like any additional questions. So I don't think I see any more questions. I thank you for joining us today, and I hope you enjoy the rest of your day. And thank you for listening to an overview of Snap Into Electronics. Take care, everybody.